Welcome to the DIY Honda Garage channel. Diagnostic trouble code DTC P2251 indicates a high voltage condition in the rear air-fuel AF sensor, specifically referring to bank 1, sensor 1. Conversely, DTC P2254 indicates the same high voltage issue, but pertains to the front AF sensor, bank 2, sensor 1. These sensors play crucial roles in monitoring the air-fuel mixture in the engine to optimize combustion and emissions. Located in the exhaust system upstream of the catalytic converter, these sensors send voltage signals to the engine control unit, ECU, allowing it to adjust fuel injection and timing accordingly. If either sensor detects a voltage higher than expected, it can lead to erroneous engine operation. Understanding these codes is the first step in diagnosing and rectifying potential problems in the vehicle's fuel management and emission control systems. DTC P2251 and P2254 both indicate an unusual voltage level being reported by the respective A-factor sensors. The A-factor sensors are critical components of the vehicle's fuel management system, which ensure that the engine receives the correct fuel-air mixture for optimal performance and efficiency. Specifically, the rear A-factor sensor under DTC P2251 is located on bank 1 and is positioned in the exhaust system. Similarly, the front A-factor sensor, described under DTC P2254, is located in bank 2. Each sensor communicates to the powertrain control module, PCM, through specific connectors, providing feedback about the combustion process. When these sensors report high voltage levels, they can trigger error codes, affecting the vehicle's performance, fuel efficiency, and emissions control. Several underlying issues may cause DTC P2251 and P2254. First, a short condition in the wiring harness between the AF sensor and the PCM can lead to high voltage readings. This may be due to abrasion, bending, or environmental factors that compromise wire insulation. Another common cause is a faulty AF sensor itself, which may be unable to provide accurate readings, thereby sending high voltage signals. Additionally, a malfunctioning PCM can misinterpret input received from the sensor, resulting in erroneous fault codes. Finally, poor electrical connections, including loose or corroded terminals, can disrupt the signal quality, leading to the high voltage condition being detected. Understanding these causes is crucial for effective troubleshooting. When DTC P2251 or P2254 is active, drivers may experience various symptoms affecting vehicle performance. A significant symptom includes reduced engine power, which can hinder acceleration and overall driving experience. This reduction may be due to the engine being forced into a safe mode to prevent further damage. Furthermore, these DTCs could lead to elevated emissions, which may potentially cause the vehicle to fail emissions testing. Drivers might also notice a rough idling condition, where the engine does not run smoothly due to incorrect air-fuel ratios. Lastly, the vehicle's check engine light will illuminate on the dashboard, signaling a need for diagnostic attention. Awareness of these symptoms allows for prompt diagnostics and repairs. The first troubleshooting step involves confirming the existence of DTC P2251 and/or P2254. Begin by turning the vehicle ignition to the on position, ensuring electrical systems power up. Utilize the Honda Diagnostic System, HDS, to clear the DTC and reset the system for accurate readings. Next, start the engine and hold the RPM at 3000 without any load for a specified duration until the radiator fan engages. This step mimics operating conditions that may trigger the sensor faults. Upon completion, revisit the HDS to check for any confirmed or pending DTCs. If either trouble code remains, it's clear that the issue persists and you must proceed to the next diagnostic steps. The second step focuses on checking the wiring that connects the AF sensor to the PCM for integrity. Begin by turning off the vehicle and jumping the SCS line using the HDS, ensuring to wait more than 1 minute. Then, you must disconnect both the PCM connector C and the AF sensor connector. This step lays the groundwork for conducting a continuity test between specific points, which are crucial for confirming that no breaks exist in the circuit. Ensure you verify continuity between the designated pins of the AF sensor and PCM connectors. If continuity is confirmed, the wiring is considered intact, and you can move to the next troubleshooting step. However, if continuity is absent, further repair of the open circuit is necessary. In the third troubleshooting step, reconnect the previously disconnected PCM connector to facilitate the next part of the diagnostic process. After re-establishing the connection, exit the SCS mode using the HDS to restore regular system operations. Start the engine and maintain 3,000 RPM again, monitoring for any changes in behavior. After allowing it to idle for approximately 2 minutes, measure the voltage across specific pins designed for this test. It's pivotal to check that the voltage measured aligns within specified limits, ideally around 0.2 volts or less. A reading within this range signals a likely issue with the PCM, necessitating further exploration into service bulletins or potential replacement. If the reading exceeds this limit, the AF sensor itself may require replacement. After completing repairs for DTC P2251 and P2254, it is crucial to conduct a final verification to ensure that all issues have been resolved. Start by rechecking all electrical connections and wiring that were involved in the troubleshooting process. This includes both AF sensors and the PCM connectors, ensuring they are secure and free from corrosion. Clear any diagnostic trouble codes again using the HDS, resetting the vehicle system. Following this, take the vehicle for a test drive under various conditions to verify that no additional symptoms emerge and that the engine operates smoothly. Finally, ensure that the check engine light does not illuminate again during or after the test drive. A successful verification confirms that the repairs were effective. To help minimize the risk of encountering DTC P2251 and P2254 in the future, implementing a preventive maintenance routine can be beneficial. Regularly checking both AF sensors and their respective connections will ensure that any emerging issues are caught early. Inspecting the wiring harness for signs of wear or damage can prevent unexpected short circuits and high voltage readings. It's also important to keep electrical connections clean and free from corrosion, as this can significantly impact the performance of the sensors and the overall engine management system. Reviewing engine performance periodically can also provide insights into how well the vehicle is functioning, thereby allowing for timely interventions before major issues arise. Establishing these preventive measures fosters a smoother running vehicle and extends component longevity. In summary, diagnostic trouble codes P2251 and P2254 relate to high voltage readings from the AF sensors in a Honda Pilot. Effective troubleshooting involves identifying confirmed issues, checking wiring integrity, and inspecting sensor functionality. Troubleshooting steps require careful attention, including verifying problems, checking continuity, and measuring voltage outputs to ensure no faults remain. The final verification of repairs ensures that issues are resolved and that the vehicle performs optimally. Establishing a preventive maintenance plan is also crucial to avoid similar issues in the future, promoting reliability within the vehicle's fuel management system. Awareness of these processes can help owners maintain their vehicles in peak condition while minimizing repair costs. Please like and subscribe to the channel. See you next time.